I want to talk to you very quickly about the concept of percentage composition. Now, percentage composition tells you what percent of a compound's weight a given element contributes. Alright, so the percentage composition tells what percent compound's weight a given element contributes, or what percent of a compound's weight a given element is responsible for. Okay, and to do that, what you do is you percent of element is equal to the RAM of that element divided by the RMM of the compound multiplied by 100. Now this RAM of the element is in its given amount. So for instance, if you have a compound where there are two of a particular element and you want to know what the percentage is, you have to multiply that RAM by 2. If you have a compound where there are 6 of a particular element, then you'd have to multiply the RAM of the element by 6. Okay, so to find the percentage composition of an element in a compound, you take the mass of that element in its respective amount divided by the mass of the whole compound, and then you multiply that by 100 since it's a percentage. So easy example to start off with. Sometimes they may say what is the percentage composition, or they may ask you what is the percentage by mass. Let's do HCl. Okay, and again, because you're dealing with masses and you need the RAMs and the RMM, that information will be given to you. Okay, so this is the formula that you are going to need. All right, percentage element is equal to the RAM of element divided by the RMM of the compound, and then you're multiplying that by 100. So let's do percentage hydrogen. That's going to be 1 divided by the whole compound, which is 1 plus 35.5. So that's 1 divided by 36.5, and then we multiply that by 100. So 1 divided by 36.5 multiplied by 100 is 2.74%. So hydrogen in HCl has a percent of 2.74%. Now, this is a simple example. So there are only 2 elements in the compound. So to find the percent of chlorine, you can either go percent Cl, and then the mass of Cl, the relative atomic mass of Cl is 35.5 divided by 36.5. And we can get it that way. Or, since it's percent and everything has to be out of 100, we could do 100 minus 2.74, and that will give you your answer as well. So that's 97.26. Okay, so as I said, you can do it that way, or you could do 100% minus 2.74%, and that will give you the same answer. All right, so you could do it that way, and the reason you can do it this way is because of the fact that there are only 2 elements. All right, for percentages, remember your percent is always out of 100. So when you add up the percentage compositions for each element, you should get 100 or pretty close to 100. Depending on the level of rounding off and stuff like that, you may end up getting like 99.99. But it should be approximately 100. All right? Let's do one more. That's a little bit more complicated. Let's do okay. Now, sometimes you'll be asked for percentage composition. Sometimes they'll change the wording of the question. They may just ask you what's the percentage by mass. Once they're asking you for anything relating to percentage, it's the same thing. Okay, so what's the percentage by mass for the elements in magnesium carbonate? And again, you're going to get the relative atomic masses. So magnesium is 24, carbon is 12, and then oxygen is 16. Okay, so you have to go element by element. So percentage magnesium, percentage carbon, percentage oxygen. You don't have to do it in that order, but you have to go element by element for the whole compound. So you need percentage magnesium. Magnesium has a mass of 24. So let me So you need the mass of magnesium divided by the mass of the whole thing, and then you're going to multiply that by 100. So the mass of magnesium is 24, and we need to figure out what the RMM of magnesium carbonate is. So 24, carbon is 12, and then we have 3 times oxygen. So we need to figure out what is 24 divided by 24 plus 12 plus 48. That's 84. So it's going to be 24 divided by 84 multiplied by 100. And that's 28.57. So this is your percent magnesium, 28.57. Now we come to carbon. So the mass of carbon divided by the mass of the whole thing multiplied by 100. That's going to be 12 divided by the RMM for magnesium carbonate, which is 84, times 100. Now this calculation here, where you find the RMM of magnesium carbonate, don't take that lightly, because you do get a mark for that. You do get a point for that. Anytime it's required for you to calculate the RMM, you will get a point for it. So don't take it simply, don't take it lightly, and don't leave off the RMM calculation, because you will get a mark for it. Don't throw away that one mark. So now we need to divide 12 by 84 multiplied by 100. That's 14.29%. Now, for the oxygen, we have a couple ways we could do that. Since oxygen is the third element, it's the last element in the compound, you could add up these two and then subtract it from 100. Or we could say the mass of oxygen, and there are 3 oxygens, so you have to multiply the RAM of oxygen by 3, divided by the mass of magnesium carbonate multiplied by 100. So you have a couple ways you can work through this. You can add up your percentages, this percentage here of carbon, this percentage here for magnesium, and then subtract it from 100. Or you can go through with the formula as well. So 3 times the mass of oxygen divided by the mass of magnesium carbonate multiplied by 100. So that's going to be 3 times 16, 48, divided by 84 times 100. So that's 57.14%. Okay, so this is your percent oxygen. And what we can do to make sure we are doing the right thing is we can add up our percentages and see how much we end up with. And all our percentages give us a total of, right there, 100. So we know we have done our calculation properly. All right. So this is how you find percentage composition, guys. Not difficult. All you have to do is make sure that, number one, you calculate the RMM for the compound. And if there is more than one of a particular element in the compound, you have to multiply the relative atomic mass for that compound by, the relative atomic mass for that element by the amount of that element that's there.